మీకు స్క్రీన్ షాట్ తీసి పంపిస్తాను చూడండి. మీకు వచ్చి సాయంత్రం వచ్చి చూపిస్తానండి. వచ్చే పంపించానండి, మళ్ళీ ఎలా పంపిస్తాను? Sir, please start the session, sir.
Okay, sir. Okay. So now my screen is visible, right?
Yes, yes.
Okay, okay. So we can open that MATLAB MATLAB software, and first thing is that I'm going to teach with the first graphical user interference. Some softwares are available in hybrid model. You know, we already discussed ANPIS. So we'll go with that ANPIS. After that, we can go with that ANPIS TLBO, ANPIS PS, sorry, ANN TLBO and ANN PSO. How to model it, how to conduct the sensitivity analysis, so that we can do that hands-on session. And after that, possible, we can go with that machine learning also. Okay, with this data, CFD generated data. First thing is that we can go with that. Doing that ANBIS and all, we can have some sort of existing codes are available. Uh, if you Google it now, we can get it everything. But no need to worry about that coding and all. Even without coding knowledge, also we have some kind of pre-existing libraries are available. You can go with that Neurofuzzy Designer in the apps and all. If you open the apps and all, you can get that Neurofuzzy Designer, that you can click, you can get it. Or else we have some command like the command anpis edit. If you click now, we can get that dropbox. So this is the what we can get it. Okay, so first, before doing that, it's a very simple modeling technique only, anpis sets up. So first thing, we need to import the data. So I have this data. I already told, so type of shape, like without having any ribbon structure. If it is like rib structure means square rib and rectangular rib. I just given the code, the numbering code, and velocity ratio like 1 to 3 I taken. So that is also done the normalization for maintaining the data consistency. Normalization are performed, and the distance also from I taken the distance of 6 points I taken. So that distance points also done the normalization. Finally, the output. What are the output I'm getting? So this estimated concentration ratio. That output also I taken as a I consider I done the normalization. After done this one, I done that randomization. After done this one, I've done the randomization. I shuffle the data. So for shuffling data, we can use this here itself. We can do the shuffle. So we can have a randomization. We can generate the random values. So type rand command. So after that under, so in the Excel itself it creates some random values from 0 to 1 range. Okay. So after that, what you can know? So we can sort this data. You can connect this one. You go to the data, and here sort. We can we have to do the randomization. So column E number, column E values are everything are random values only. So with the help of this column E, I want to do the randomization. After click OK. So now randomization one done. So entire data was the shuffled together. So once the shuffling was done, we can remove this one. So we can do that. We can remove this one. After that, uh, after that, the next step is that first normalization, randomization. After that, data splitting. So data splitting here, so I consider the standard data splitting value 80 is to 20 ratio, or else you can go with that 870 is to 30, or else 90 is to 10. And sometimes, like if data points are very less, like 27 data points are there, so what you can do? So one value, so single value, we can go for the testing value, and the remaining 26 values are going for the training value. So in this 26 value, once that model was done, and next second value, it will be considered as a testing value. Remaining 26 value will be considered training. Like 27 times the model was developed. So that is the for low, that is a general practice for low data sets. So now I have a significant data set, so it is around 90. So I don't want to do that kind of practice. So it is I can go with the splitting. So the splitting was done 80 to 20. So 80% data points among all 72 data points are going for the training, and the 20 data points are a whole for the testing values. Okay. So now, so this data I just want to dump over here. So now this data was pre-processed completely. So now this pre-processed data was I was just want to store in the workspace. So here create that train value. Data was create a new workspace here. So train value, and similarly test data also I need to pass it. Okay. So now click over this here train value. So go to the training data set. So select all, go to here and paste it over here. And now the beauty of now ANPIS is, suppose if you go to that NN modeling and if you depend on the graphical user interference, so first input values we need to give separately, and the target value like output value, target values are you have to give separately. But in ANPIS and all, the least column, the last column, by default it will be considered as a output value. So that is the thing. So now enter data. So first three columns are will be going for the training, sorry, input value, and the last value will be going for the output value. So like such a way that the code was uh, written. Now similarly in the test data samples also we need to dump it over here. And after that, once the models was ready, I need to I need to estimate that, predict the value. So for that I need to pass only the input values. I have to pass the only training input value. I need to pass only testing input value. So that I need to create the new workspace. So I have to create that for validation purpose. So creating the value test. So now go to the training. So what you can do? So training all input values only I'm passing here. So this is the one. So only input values. And similarly testing also only input values only I'm passing over here. Now my data set what data was dumped in MATLAB in the workspace. So now we need to take that graphical user interface tool. So ANFIS edit. So type this code. Or else you can go to the apps and you can check that neuropathy inference. If you click that one, you can get that also. So you will get this uh, Dropbox. Now we need to import the training data, testing data separately. So now your data was somewhere in the file. You can load data from file. You can check. You can connect to that your libraries. Or else if you already stored in the workspace and all, so you can click this from workspace. Why? Because already dump the data in the workspace, and now you can load the data. So what load data you want to load? So in the training, I will just load it in the train value. So that name we have to write over here. So try. So just be careful about that. These parameters are case sensitive. So what are the name you are giving? Same name only you have to type it over here. So it will be case sensitive with the capital letters. And similarly, in the testing also, you have to load the data. So in the testing, so you can type the test value and click OK. Okay. So now data was ready. So now first, we need to generate that fuzzy inference system. So first load the data, generate the fuzzy inference system. After that, train the fuzzy inference system. So for here, what you can do? So here, for the grid partitioning system, there is a two types of fuzzy inference systems are there. One is the grid partitioning system and substantive clustering. Or else if you design your own fuzzy inference system, you can load from the file or you can load from the workspace. So mostly these default fuzzy inference systems are sufficient. If you want to customize your own fuzzy inference system, so you can write your MATLAB code and you can input from here. So it is allowing the your customized codes also. Okay, and now grid partitioning system. If you click over here, so now it is asking two type of membership function. One is that input membership function, and second one is the output membership function. In that here it, we have several type of membership function. What is actually the membership function? So first, what are the data it will there? The data was first it will be converted into linguistic values. So in the linguistic value, so what are the data you are passing? So the output should be in the range of 0 to 1, but once it touching to that particular shape, so corresponding values only it will be extracting. So if you take triangular membership function, we take triangular membership function. So triangular shaped membership function only it will be visible. And if it is trapezoidal membership function, if the shape membership function shape was look like trapezoidal. And Gaussian bell uh, G bell membership function is nothing but Gaussian shape will be there. Gaussian distribution shape will be there. And this is another category of Gaussian distribution membership function. And pi shaped membership function, we have this kind of membership functions will be there. So what what sensitivity parameters we can adopt here? So here first we need to fix with that membership function, that is a triangular membership function. After that output membership function, we have another two classification, that is a constant or linear. So first you can click that constant value. After that click OK. And now here so here the training will be done either by backpropagation or hybridization method. So so ours actually this ANFIS model is backpropagation technique it will allow. So it is a combination of neural network and fuzzy inference system. So I just checking with backpropagation technique only. So just give some iteration how many times it will be iterated. So we need to fix the goal. So, the goal must be either minimum mean square error value or else approaches value. But if you have a customized code, you can fix that minimum error value. But in ANFIS and all, it will take only number of iterations. So maximum iteration you can give. So if you give lots of approaches, more approaches, it will take a lot of time to get that more accurate value. Okay. Now just for understanding purpose, I given only 25 approaches value. Now you can try in that data. So now your training was done. Training and testing also both are done. Now you want to check the structure. So this is the structure. So now the rules for these are the actually layers. The first layer actually we are passing the input layer. First layer we are passing the input layer, and the second layer actually membership functions are we are passing. So now what is a membership function? How many membership function we are generating? Three membership function, but that membership function was the triangular membership function. So now the input value was passed over here triangular membership function. The now data was generated. So that generated value will be going to the now here the rules will be passed. Here the rules are nothing but pacification. So once, sorry, pacification. After the pacification layer, this is the pacification layer. Once the pacification is done, normalization will be done. So normalization, and after that here the denormalization. Finally, the output will become. So in the normalization, the data which will be there, that here rules will be applied, and normalization will be carried out. And after the depacification and the output membership function, here we need to give that output membership function we already given in the constant value. So first order polynomial equation only it will be considered. So here what are the values of weighing some uh, normalized falsification value will be multiplied with the this value output membership function. So once it is multiplied with the output normalcy function, we will get that final value. That here all the values will be summed over here. The finally summed value will be coming as a output value. So this is what actually structure will be developed. So why it is three? Why? Because I taken if you consider three input values. So this is the type of shape. This is the type of sorry velocity ratio, and this is the position of the micro passive micro mixture. So this is what the data it will be passing. So finally the output was concentration value. So constant. This is the structure was developed. Now you want to check that how accurate, how exactly it is predicting. So you can have the plot against some curves like training data and testing data. And training data, if you check it, so it is not actually approximately predicting. So the data was a lot of deviation was there. So if you check the testing data also, that is also there is a lots of deviation was there. So it is not actually properly predicting. So we can go now. It is not fit. So we can check with that some other sensitivity parameter. So now this is some model was developed. So this model I just want to store it. So how we can store? So go to that file, and here export to workspace. So here you can give the name. So for your understanding, so what kind of parameters you are changing. So first thing is that input membership function is a triangular membership function. Output membership function is a constant membership function. So we can give the try and constant for better for understanding. Why? Because you are generating lots of ANSYS models. So when you are passing the data, so you bit little bit confused which model are passing. So for understanding, so input this is the parameters you are changing. So that's why you can give the triangular membership function as input parameter, and constant membership function is for the output membership function. So now the model was stored here in the workspace. So now model was stored here. So now what you can do? So I just want to predict that anyhow that is not predicting properly. That value you want to you want to store. So what you can do? So you have to evaluate that model. So you have to evaluate that model. So you already having that trained model and testing models, testing data. So without output value, you have to pass that value. So here we have a code like for extracting that predicted value. So we have a function like eval fis. So first we need to pass that what is the data. So what is the data you want to predict? So I just want to predict that valid, right? So only input data only it is there. So it doesn't have any output value. So how accurately it is predicting? I want to test it. So valid, right? Now on which model you are passing? So what is the model I'm passing here? Triangular membership function. So we should be very careful about the session case sensitive values. Why? Because it is fully case sensitive MATLAB code. So now it is predicting. So now it is stored in the value, answered value. So this is actually you got the value predicted. So this is the triangular membership function, constant output membership function. This is the value you are predicting. So and similarly, and for testing also you can able to predict. So for testing, again same you can write it eval FIS code. Eval means evolution of FIS code. So here what is the data you want to pass it? Validation of testing. So valid test. So now, what is the model you want to pass? Triangular membership function, constant value. So this is the tested value. It is predicting, right? Now, similarly, you want to generate another model. So, like again, handpiece code, handpiece edit you can do, and here load the data. Space. So the space load the data. Right? Similar procedure we have to follow. So testing, test data. So now again that in a generate affairs model, grid partitioning system. So now actually this is also one of the cases to sorry sensitivity parameter. Now at each and every membership, now it is actually three numbers are generated. So at each stage three numbers, same three numbers membership functions were generated. Now you can change to five, you can change to four. That is also you can, that is also will affect that prediction performance of the developed model. So by default actually I'm going, so you can change to the number of membership functions also. So that combinations also we can do. So now triangular members, now I can go with the trapezoidal membership function. So I just fixed with that output membership function. Once all these membership functions are changed, now similarly you can change to the linear. So like that you can do. So now model was developed. So and I can go with that either hybrid or back propagation. So I'll go with the back propagation. So I can give that zero value. So now after 30 approaches, I got some value. So why this value was not predicted? Even though some you have to, whenever you are running these models, you have to give the maximum approaches value. So like 1,000 or 5,000 or sometimes 10,000 approaches value to give. So error value was minimized. So like that it will be generated. So for understanding only, I'm giving only 30 for time constraint. I'm giving only 30, but you can run up to 1,000, 10,000, so get that better values. So this is the now tried, it is done. Now what is the structure was created? So I already told that here the number of membership functions are three. So now three input membership function. So based on that rules will be developed. This is the pacification which is done. After that normalization will be done. So once the normalization rules are formed, those will be multiplied with that uh, first order of polynomial equation. After that, the summation will be done.
లేదు ఏంటి నువ్వు ఎందుకు జాయిన్ అవ్వలేదు అడ్మిషన్ లింక్ లేదు అని నీకు పంపాను కదా లింక్
Okay. After that, so now you can check that how the model performance. This is also not showing good, and like that you have to keep on doing. So keep on doing. So like testing that also not done properly. So this also we need to export for export to workspace. So here this is the triangular trapezoidal membership function, and here constant only. It is export in the workspace. So it is done now. So it is exported into here. So what you can do? I already told. You want to predict the data. Eval FIS. Eval FIS. Now we can pass the input data valid. Valid right. Trapezoidal membership function. Come now. Cons. This is what actually the value was predicted. So every time what are the values are coming, so we need to save it over here separately. So we need to compare how much accuracy it is coming. So for getting accuracy and all, we cannot simply visually confirm it. So we have to do some statistical analysis. So for that, we need to find out that RMSE and R square value. So we have some empirical formulas for RMSA value. R square value it is nearer to one. So that based on that which is having the highest R square value, which combination will be having the highest value, that is the best one, and which is having the lowest RMSA value, that is the best one. Like that, we have to choose it. So here the what are the possible sensitivity parameters will be there here and ANFIS and all. So once the load the data, so here that generate FIS function. So in the generation, so input membership function, output membership function. So seven here there actually seven will be there. Here output membership function two. 7 into 2 14 combinations will be there. Apart from that, even number of membership function. It is by default it is taken as a 3 3 3 combination, and you can increase the number of membership functions also. You can go into 4 4 combination and 5 5 combination, so you can do that, and that is the one another sensitivity parameter. And even though approaches the number here, that optimization method, sometimes it will be hybrid optimization will be considered, or sometimes it will be a back propagation optimization method will be considered for training that fuzzy inference system. So these two combinations also one of the sensitivity parameter, and approaches should be as maximum as possible, then only you will get the more accurate value. So every time you can run this system, after that to export that model to over here in the workspace, and after that use the command code like eval FIS. You can pass the only input data, not output data. With only input data only we are passing. After that, developed model also we are passing. Then you will get that. Then you will get that final one. So this is the way to do that modeling in the ANPIS. Okay. So now it is clear. Now we can move with that second hybridized algorithm, like most popular algorithm NNTL view that we can discuss.
Excuse me, sir. Hello.
Sir.
You have you got a data set uh,
Okay, sir.
that you have shown in previous lecture
Yep. Yes,
in
sir.
CFD. From that data set, actually, what is our objective in this problem?
Yes, sir. Actually, here I'm not conducting that experimentation. I have just conducted only CFD computation only. So in that
Okay.
computation, also,
Uh,
what happened now? Here several type of shapes we created, and different velocity ratios we are conducting. So at each and every location, I'm going to estimate the concentration ratio. So repeatedly, I want to do means it takes a lot of time. So I just have some combinations are created in the CFD. So after once it is done, so once the model was predicted, once model was developed, next time and all, no need to depend on the computer efforts and all. So simply, I just simply once model was developed, I can pass the data. I just all pass the data. Now, suppose unknown parameter. So now unknown parameter I want to pass it. So what I can do, I simply send that. I just create that one experimentation. So CFD and all, I just type of shape, and 1 to 3 combination are taken, so velocity ratio. Apart from that, some unknown value 2.25 velocity ratio, I want to check that concentration ratio. So that value I just pass it, and after that at particular location in the length of the micromixture, I just pass an particular location. Those data if you pass now, so obviously I'll get the data. So I don't want to depend on that every time in the computational fluid dynamics. So I cannot run that now.
Just a minute, sir. But when the geometry will be changing,
Hmm.
the fluid parameter also get changed.
Obviously, so that also changing. So here, why I'm clubbing all these models, So
Uh,
here, if you individually you are creating means for without ripple, actually it will create another model, and for squared it will create another model. Like 5 models I have to create. If you club no, so one
Hmm.
model itself, it is a gunshot. We can predict any kind of data.
Means
That
you
is
are telling if it is a prototype model, then you can use your statistical feature.
yeah, statistical features.
But before that, your this type of message, whatever you have shown,
Hmm.
it cannot be predicted. I think what I understand. I don't know.
Which one?
Means this modeling stage can you use directly? For example, we are evaluating modeling through a pipe, CFD analysis of pipe flow, a
Yeah.
laminar flow cases.
Okay. Yeah.
Okay, sir.
Hmm.
So, for any instant, can you predict the algorithms?
For any instant is not possible. Anyhow, for modeling, for any hybridization model and machine learning, whatever it may be, we need data. So that
Yes,
data may
yes.
be from CFD or it may be from experimentation.
Yeah.
But experimentation actually is too expensive. So what I can do,
Yes,
I
yes.
can develop CFD model, numerical model.
Yes, sir.
So once the models are ready, so we have to do that combination. Because you can conduct the parametric analysis and we
Means for
can
the same parameter of pipe, we can go for.
yeah.
But if changing of the model, it cannot be predicted if I am correct.
What kind of model?
The geometry features, shapes and
Yeah,
size.
yeah, exactly. For changing the geometry model, it is not feasible.
Yeah. Okay. Okay.
But
Yes.
internally, what are the parameters which will affect that handle? We can able to predict. That is possible.
Yeah. Yeah.
Mm.
Sure, sir. Thank you.
Why I'm considering this one? Once again I'll tell why, because if you're not considering this number of type of geometry, so for each and every geometry, some parameters will be there. So for every geometry, I have to create one separate machine learning algorithm.
Okay.
So that is actually a headache task. So if you
Mhm.
club this data, so what at any instant of time, whatever it may be, so whenever you want to predict that particular geometry, I can simply affecting parameter if you pass in the model, it will predict it. That's all.
Gotcha.
Otherwise, every geometry we need to create your own machine learning model. So
That,
10
that
geometries.
I that I am able to understand from this. Yes.
Okay, okay,
Yes.
okay.
Thank you.
So, okay, so now this is the ANFIS model I'm discussed as of now. Now we can go with that hybridization model like AN and TLBO. So I have a developer code. So straightforward, I'll go to that code. So this is the code actually I was developed for. Actually, ANN actually how it will work. I already told. So we have a structure like I'll go with that structure. I will explain perfectly. So let us take this is the typical ANN neural network, ANN network. So here actually feed forward method. I already told two types of methods are there: feed forward approach and the feed forward back propagation approach was there. The feed forward input data will be passing into the input layer. After that, it will be going to the hidden layer. After that, it will be going to the output layer. So each and every neurons will be connected to the weighing balance and sorry weighing, and after that it will be linearized with the help of BIOS, and after that from hidden layer and output layer again it will be having some weights, and it will each and every output layer it will be having some BIOS for linearization, and from data will be passing from summer value of weights, it has to pass through that activation function over here, Here activation function will be there, and here also activation function. Like that, once weights and bias will be generated, and data will be passing, and finally output was predicted. This is actually feed forward. So this is the typical it will happen. But in the back propagation, it will data will be passing over here. It will predict some value. Based on the value, error value, the weights and bias will be optimized. In the first session, I already discussed about that how weights and bias will be updated based on the gradient loss function calculation. So weights and bias will be updated. Once the weights and bias will be updated, now data was again passed here, and it will be loss factor value, loss function value will be calculated. Now it will be reduced. So again, based on the error, these weights and bias will be updated. So these iteratively several times it will be done, and finally you will get some value of best value, best predicted value. This is what actually back propagation will done. But if you use that any instead of back propagation, so you can eliminate that back propagation approach and weights and bias. So now here the weights and bias will be considered as a population, and fit, error value we can consider the fitness function. So if you do like that, so we can integrate this ANN model to any of the bio-inspired algorithm like genetic algorithm, particle swarm optimization algorithm, like teacher learning based algorithm. Like that you can club together. So here the first weights and bias will be generated. After that, error will be calculated. So now fitness function value will be considered the loss function. Now weights and bias will be considered the population. So based on that, now TLBO will be activated. So here that based on the teacher phase, learning phase, some sensitivity parameters we need to change. So after that, so once that weights and bias will be optimized, so this will be done until you are getting the least mean MSC value, so least error value. So once you get the least error value, the weights will be optimized. The now optimized weights will be considered as the best neural network. That is the hybridized neural network. So this practice we can do any kind of bioinspired algorithm, like we can connect to the genetic algorithm, you can connect to that particle swarm optimization, we can connect to that teacher learning based algorithm. So now I'm taking teacher learning based algorithm. This is that AN typical ANN code. I'll explain one by one. Now how this will be connected. So this we need to integrate. So what is that algorithm I'm considered? TLPO, teacher learning based algorithm. So this we can check it in. You can Google it and you can get, yeah, these codes. MATLAB codes are available. So not only TLBO, and recently what are the recent bioinspired algorithm like Gray Wolf algorithm, or it's like ant bee colony algorithm, whatever it may be. So some existing codes, MATLAB codes will be available. So you have to copy paste all this code here, and here we need to call the function. We need to call the function in this any every bioinspired algorithm having set of sensitivity parameters will be there. So like here, uh, number of population, maximum iteration, and variable factors and cost function. These are the parameters which will be influence the teacher learning based algorithm. So this function, in the function value we need to call this function, and this will be connected to the ANN. So how we can connect? So here in the ANN, yeah. So here this we need to connect over here. So optimization algorithm with we have to connect here over here. So now, and here parameters also. First we need to pass the data. So, and this is the error function value. So error function value has to be optimized. So now this is the fitness function is the minimum value, and the error function value has to be fitness function value, and weights and bias, what are the weights and bias which is generated in the ANN. So that will be up that will be optimized using the TLB, like some it will be some having some connection. And now, so now we need to give the data. So first, so here and all. So here, actually what data where actually you want to pass it. So here inputs, actually input data we need to pass, and target data we need to pass. So this with same naming we need to generate in workspace. input, target. So now we need to pass the data. Now what you can do, we have to train the data first. So again, same procedure. We have a raw data. We need to do that normalization, randomization, and split the data. And now, so this is the input values. We need to dump over here. So now data was dumped here in the workspace like input and target. Now, so here your data input values are how many numbers. So here input my input numbers are actually three. I have three input data. So here the n value number of decision variables. So here this code we need to change. So here the number of decision values are actually three. So we'll multiply with the three. And now, so here AN and TLBO typically three sensitivity parameters you need to change. First thing is that first feed forward network ANN only one sensitivity parameter will be there. That is actually hidden neuron. So hidden neurons we need to change. So that is the n value. You can give the range. And second one algorithm we need to algorithm we need to optimize. For optimizing the algorithm TLBO, it will depends on only two sensitivity parameters. The one is that population and iteration. So first, how we can go with the approach. First, what we can do, first number of hidden neurons. So what is the number of hidden neurons will be there. So yeah, how you can do that. So there is some formulation will be there. So input plus output divided by 2 plus root train data. So first we need to do like that. So how many input parameters are there? Here three input data parameters plus how many output parameters? That is the one input plus output. So 3 plus 1. So that is 4 divided by 2. So now 2. The 2 will be plus to root train data. So how many train data will be there? 72 train data. So 70 root 72. So approximately you can take like around 9 value. So 9 plus 2 11. So 11 range you can take. So in this 11 range, so plus or minus you can take 10 or plus or minus 5 you can take. So that, but it will be fall in that range only. So it is not exactly that 11 value, it will be fall in that range only. So that's why you can give that range from 8 to 9. So for understanding you can give uh, suppose 11 you are getting, so plus or minus 5. So 11 minus 5, so how much value it is? 6. From 6 to 11 plus 6, so that is 7. 6 to 17 range you can check. For understanding I'm giving 8 9 10 only. For otherwise if you do run like that it will take a lot of time. So what you can do, from 6 to 6 comma 7 comma 8 comma up to 10 up to 17. Suppose if you take plus or minus 10 range, so you can give 11 minus 10, so from 1 to 21 range. So that's your so mostly from the literature availability it is showing like that it is in the plus or minus 5 range only they are considering. So you can choose plus or minus. Otherwise you want to check in if you want to explore in more, you want to check in more exact values, so you can go with that plus or minus 10. So this range I'm checking. So for understanding I'm giving this range. And after that another sensitivity parameter, that is population. So here the population is also uh, it is one of the sensitivity parameter. Lesser population it will take better value. If it is what is called so less it will easily get the data easily. Solution will done simple only. It takes less time only. But if you give more population, like more number of population values, so what will happen? It will explore in all the weights and biases. So obviously, it will take a lot of time to get the value. So you have to check that range also. So mostly, I can check that first I can fix that range of this one neural range. After that, I can go with that population range. So once these two done, so at this best combination, so we can go with that maximum iteration. So sometimes we can go with that for understanding and given only 10, but if you go with that 10 to 10,000 iterations or 10,000 iteration, you will get the more accurate values. Okay. So now these results where you want to save. So I have already. So these results where I want to save. I have to give that location. So base directive location I want to save. So copy this path. This location, in this location only my results will be saved. So if you give this location, so I'll just copy this location so for saving all these things. And now my code was updated to earlier. Actually, if you check it in MATLAB, the mostly people will perform integration ANN and TLBOR, ANN, GO, whatever it may be. Integration you can do easily, but how long it will take? So if you go with that higher populations and all, it takes lot of time to. It will take lot of time to get the result. So for other time, so single sorry at the time what will happen, for one system and all, it is not quickly do that this computational calculations. So we need to connect that more cores. So mostly our laptops also some cores will be there. Suppose if you go with the workstation, so it will be having different cores will be there, like from having 12 cores, it having 6 cores. So parallelly we can run that system. So my code was updated like that only. So wait a second. So here that I'm this is that parallel computing I have performed here. So powerful actually for parallel computing. So it will run all the cores for your system. So after that, each and every cell, if each and every cell some values we need to predict. So predicted values are hidden weights and neurons for each and every combination. I need to save in the separate excel file. So that directory already given here. So here I already given the directory. So all this data will be the weights and predicted values and everything will be stored in the particular directory. So first this combination I want to check. So what I can do, I already dumped the data. So go to the workspace. The workspace input data given, training data 80% data, and target is also 80% data. This is the output value, this is the input value. Same values only I'm passing over here. Same values only I'm passing over here. First, only one sensitivity parameter will be changing from 6 to 8. Now, number of neurons only changing. I'm not changing population size, maximum iterations. I'm changing only this value. So number of neurons only. Once the in this number of neurons, if you're getting the values, so the predicted value, you have to perform the statistical analysis, like RMSE value, RSR value. We have to calculate for the neuron each and every combo of neuron. And one, suppose I want to check from 7 to 8 range, 7 to 8 range I'm checking. I got some predicted value. So in this predicted value I have to compare with the actual value, so I can apply that statistical analysis. So RMS value, RSR value I'm getting. So in this combination, suppose 7 value at 7 hidden neurons, I'm getting the best value. I'm getting the best value, higher RSR value, lower RMS value. So that is the best. So what I can do, so now you can fix this one. Now you can remove all these things. So you can fix the number of neurons is 7 only. Now you can vary the population. Now you can vary the population. Now you can vary the population from some your specified range. Like you can check, you can go with the 25 to 400 range, or you can go with that 50 to 1000 range. That you can. This is also trial and approach. So you can check in that range. So again you have to run. So you will get that some predicted values. So that values, again the predicted value. So now best at best neuron, at the best neuron, uh, at all population sizes you are checking. So in this combination range also, in particular population, you will get the best predicted value. So and that fixed, suppose you are testing from 25 to 400 range. In that 400 range, you are getting 200 combination is the best one. Now earlier actually 7 you got 7 neuron, and 200 is the population is the best. Now these two are best one. So now you fix this one, 7 and 200, and now you can vary the maximum iteration. So you can vary the 100 iteration, you can give the 200 iteration. Now you can change the higher um, range from 100, 200, 300, 500 up to 1000. You can go up to 10,000 iterations also. That's your system capacity, your system capacity, and uh, your what do you call, like up to what error you are compromising. So that's your wish. So up to that you can do that. So now I just want to check in the number of neurons from 6 to 8 range only. Now I'm fixing that, initial I'm fixing the population was 11 and iteration 10. Now you can run the system, and values are already number over here. So now it is doing, code was running, and taking parallel computing. Why? Because it checking how many cores are available in the system. So if it is suppose 6 cores are there, all the 6 cores will be working parallelly. If it is only one core system is there, by default that will be working. So mostly these now iterations was done. So up to, how many iterations are given? 10 iterations only are given. So now this is which combination. So first it is checking 6 neurons, and population was 11, and now iterations 10 it is checking. So now it is start again parallel computing. It will go for the next iteration. So now it is go to that next neuron. So seventh neuron, and population 11, and iteration 10. 10 iterations is done. Now it is go again, it is calculating again. So parallel computing, it is checking. So now it is calculating for eighth neuron. So 10 up to 10 iterations it will done. So now it is stop. Now it is stop. So this range actually it is done. Now what actually happened? The data was stored in the best neuron. So now I'm checking only in the a range of neuron range only. So I can check it in this range. So best neuron. So what combination? 6, 11, 6, 11. Sorry, already pre-existing data was there. So it is checking in this range. What range? 6, right? So it is saved like 6, 7, 8. Population was 11 only fixed here, and iteration was 10 only fixed here. So you have a data. So what data it will be stored at each best cost? Everything it will be saved here. So now the predicted value, if you check, you see. So likewise, actually it will be saved. So at each and every combinations, like if the values was predicted. So these values, the every combination you are getting predicted values, So this predicted value you have to compare with the actual value. You have to calculate the RMS value and R square value. That you can do that Excel calculation, or else you can develop your own code for calculating the RMS value and R square value for each and every combination. So best, suppose now I'm getting the best value here. So in this combination, sorry. So in this combination, 7 actually I'm getting the best RMS value. Now what I can do? So I can change the population range. So let us take. So now run this code. So let us assume that seven is actually giving the best value. So best RMS and RSR value. So you can fix that neuron number of neurons 7 value, and now you can vary the population size. Now actually for time constraint, I'm taking only limited population only. But if you go with a higher population, you get the more accurate value. But computationally, it takes a lot of time. So now it is checked. 11th population, 7th one, 11th population, and iterations has completed. Now it is checking into 12th population, and 10 iterations was completed. Now it is calculating for 13th population, and iterations was 10. It is calculating. Every time it is doing the parallel computing. Okay. So now it is saved. Now it is saved. You can check it in the files. Best population. You see, now 7th neuron, 11th combination, and 12th combination, 13th combination, iterations. Now it is saved like that. Okay. Now you can here also data will be predicted. We'll have a data. So some compatibility issues, I think. Okay. So now these are the predicted values. So for 8th is the best already fixed from that range. So once it is done, now we are checking from 11 to 13 population range. So you're getting some predicted value. So once the predicted values was, we have to compare with the actual value. So based on RMS and RC value, which is the best combo. Now let us take 7th let us take 12th is the best one. Let us assume that. Now you can, what you can do, so you can check it, you can fix this one. Now 7 is fixed, and now 12th is the best one. Let us check that iterations range. Now give that iterations. So this range you want to check. Now what I can do? So now it is checking for 7th neuron, 12th population, 10 iterations will done. Now it will go to that 7th neuron, 12th population. Now 12 iteration has to be done. We will do like that. So now 12 iterations was finished. Now it will go to that 14th iterations. So now 14 iterations was finished. So now it will be stored in the your directory files. So you can go to that maximum iterations. Now you see now there is a combination, and you can have a best neuron 7, and you have a best population 12. Now here you have a data. So here also you will get that predicted values. You see, so these values you have to compare with the actual value, and again calculate the RMS and RS value, which is the best one. Now 7th neuron, 12th population. Now maximum iteration is the best one. Now that final combination is the best model, and that model weights and bias. Suppose 12, 14 to 1. So in that model, those weights. Suppose in that model, so you will get that weights. So these weights, if you pass it over here, suppose. So these are the weights. So input weights. Let us take. So these are the input layers. Now how many weights are coming here? This is the matrix was developed. So input to hidden layer. So how many hidden neurons will be there? 7. So that's why 3 by 7 matrix will come. 1, 2, 3, 4, 5, 6, 7. So why? Because 7 is the best I'm getting. And input layer how many? 3. So type of shape and type of velocity ratio, and finally position. That is the input data you are passing. So 3 by 7 weights is coming. So but bias and all, for hidden bias, how many? 7 has to come. So 7 bias will become here. You see, 1, 2, 3, 4, 5, 6, 7. So why 7? Here is a hidden neuron. Sorry, wait, I will show that image. You can get some clarification. So here actually weights. So 3 weights, 3 into will be connected to 7. So 3 by 7 weights combo will come, and here weights. So what is the weight here? Sorry, it will be having the bias. So the bias value is 7. So 1, 2, 3, 4, 5, 5 actually, but my network actually 7. So 7 biases will be there. So but similarly, and output also, but output structure is actually 7 hidden neurons will be there, that will be connected to the only one output. So 7 by 1 weights will become. You see. You see. Sorry, right. 7 by 1 actually come. But finally, bias and all, only one output will be there. So one bias will become. Only one, right? So with the help of these weights and bias, you have a empirical relations. You already know how weights and bias will be connected, so you can have a complete structure. So now next time onwards, with the help of these models, so with the help of these equations, you can deploy to the any of that IoT system. So we either be connecting that, you can write the equation. Why? Because you know that activation function, you know that weights, you know that bias, so we can easily to write. So only that unknown parameters are inputs only. So x1, x2, x3 only has to pass. So if you pass that unknown value over here, it will be calculated the weights, and it will be multiplied with the weights, and it will be summed with the bias, and it will be transferred to the transfer function. It will be finally output will be come out. So likewise, your network will be developed. So once the network will be developed, so based on that network, you can create that equations. In the first lesson, I already told how structure will be developed, how the weights and bias will be developed, how the equations will be formulated. So similarly, here also equations will be formulated. So you can pass the data, unknown data. So network will be optimized, network will be done, and output will be effectively predicted. So these equation you can connect it to the any of the IoT system. So your design will be simplified. So no need to like, I'm just taking only the CFD analysis I'm considering, but in practical application, any kind of data you are predicting and you want to make some IoT based model, and you can create your own graphical user interface tools with the help of this equation. And if you pass that value, and the output value will be come out, so it will reduce your experimentation effort. And similarly, this with the help of this equation, and you can develop your graphical user interface, some small uh, web-based system will be you can develop, you know, that equation. So you can give the type of shape, you can give the dropbox like that, you can give the type of shape, and you can give that velocity ratio value, unknown parameter will give, and output, and at particular location what is the concentration ratio. And you already back and the equations will be developed already. So those equations will be run, and if you click predict, and finally output has to be done like that. You can create some web based graphical user interface also, you can able to predict. So that is actually very lengthy session. Yeah, but I will share some videos regarding that, how to develop how to deploy these developed models to that web based systems also. Okay, so this is about AN and TLBO. So not only like AN and the TLBO, you can connect to the, if you, any the bio-inspired algorithm will be coming in the market, so that can be coupled to the ANN. So simply I'll show ANN PSO algorithm also, but I don't want to take a demonstration, but I will explain the simple code how you can connect it. See, so this is the ANN PSO algorithm. So this is actually a particle swarm optimization algorithm completely, and it is the main function will be having the neural structure. So finally, every time here also some sensitivity parameters will be there. So what are the sensitivity parameters? Here the n value, number of neurons. First ANN sensitivity parameter, number of hidden neurons, we need to change it. So that can be you can check it here also. You can write it like what earlier what I had developed. No? Similarly here also you can write it, but I haven't used this model, but mostly it depends on the NNTLGO. Why? Because sensitivity parameters are very less in the NNTLGO. But coming to the NNPSU, this is also okay. Number of this parameter, number of hidden neurons range we can set, and one more interesting parameters are C1 value and C2 value, cognitive coefficient and social coefficient. For PSU, actually, it is what are the sensitivity parameters? You know, cognitive coefficient C1 value, C2 value. This also we can put different combinations, and we can give one value and C2 value give 2.5, and sometimes you can give 1.5, and sometimes you can give 3.5. Like that, we can give different combination, and this sensitivity parameters also we can check it. And one more sensitivity parameter also will be there, that is number of populations, p value. So here p value actually 10 initially tested. You can also give the range from 25 to 400 range, or 100 to 1000 range. Like that, you can check that range also. And one more sensitivity parameter is iteration. So here the iterations actually number maximum iterations will be there. Mm, yeah, yeah, the maximum iterations actually 1000 iterations is given, but you can check it from the 1000 iteration to 10,000 iteration, you can check it. So here also same kind of sensitive analysis, you can check that number of neurons, and which is giving the best one, the fix that best neuron. Now you can go to the cognitive coefficient value, social coefficient value, you can check that different combo. Now you are getting 1.5, 2.5 is the best one. Now you can fix the number of neuron one, and the C1 C2 value fixed. After that, next go to the maximum populations, sorry, number of population. Now which is the giving the best value, so you can pick that one. After that, you can go with the maximum iterations. So finally, so these are a lot of sensitivity parameters which will involve. So but if you go to the genetic algorithm, so here actually genetic algorithm, uh, ANN actually neuron we need to change, but genetic algorithm mutation rate, crossover rate, like 10 parameters will be there. So if you run this ANN geo algorithm, so it takes a lot of time to get the predicted value. So that's why whenever you want to you want to hybridize that algorithm, so any optimization algorithm to that, you have to connect to the ANN. So we should be very careful that which is having the very less sensitive parameter that can be adaptable. So as of my suggestion, now ANN tailwind is somehow better. Why? Because it having only, anyhow we need to change the number of neurons. Apart from that, in the bio-inspired algorithm, here only two parameters are changeable, that is population and iteration. But recently one more algorithm also which is very famous, that is J algorithm, doesn't have any population, only iteration will be changed. So that is even better than the AN and tail. So that is also I'm working on it. Okay, so this is about that how to do that hybridization algorithms. You how to couple this bio-inspired algorithm to the ANN to get the better predicted value. So this is the thing. So you have any doubts? Do you have any doubts on this code? Any concept related questions? Hello, sir.
Any questions from the participants? These are calls.
Any questions, sir?
I think no questions from the participants, sir.
Okay, sir.
Okay, thank you so much, sir, for your wonderful session.
Okay, sir. So, can I end this session, sir? Or shall I wait for any questions?
I think nobody is responding. Okay,
Okay.
sir, we'll end the session. Thank you, sir. Such
Okay.
a
Thank you, sir.
wonderful uh, knowledge.
Okay. Thank you, sir. Thank you so much, sir.
Thank you.